Welcome to Walkabout the Galaxy, the hurricane-ready astronomy podcast, where the science is universal, the opinions are personal, and the weather outside is frightful. Not really. It's delightful, actually.
For now.
For now. But we are anticipating the arrival of Hurricane Ian.
Which is the most, underwhelming name for a hurricane.
They frequently are, and then the reality changes your whole perception of that name.
Yeah.
We are Strange, Charm, and Up, the Astroquarks, also known as Josh Caldwell,
Addie Dove,
and Hannah Sargent.
Coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram. The Walkabout studio will be closing in 2 days, we've learned, because of Hurricane Ian. Our YouTube videos now feature chapter breaks, so you can cheat and go straight to the trivia answers, but you two can't, because it won't be on YouTube until after you have already had to answer the questions.
Darn it.
You can contact us anytime at wtg@ucf.edu.
I thought you said YouTube can't.
You said
YouTube.
Yeah.
YouTube can't.
I was like, what? I don't know. Maybe it can now.
Contact us anytime at wtg@ucf.edu and order a Walkabout t-shirt in sports STEM education. Our Stumper today is a little bit derivative of a former Stumper. I think it's one of the choices we have encountered before, but I don't remember what it was.
Probably Hannah hasn't.
I haven't.
But I don't think Hannah has, because I know it was a Jim Stumper before. Anyway, speaking of hurricanes arriving, we're very eagerly and nervously tracking the information about the arrival of this particular hurricane here in Central Florida, with data provided by the intrepid pilots of the Hurricane Hunter spacecraft.
Nope.
Your Stumper is...
Airplanes.
I said spacecraft.
There is spacecraft data that's used for hurricane
astronauts.
tracking. We use a lot of
Give me a cookie.
we use a lot of satellite data for hurricane tracking.
Yes. I don't know why I said that. Maybe because I think about spacecraft sometimes.
We think about spacecraft all the
That's
time.
probably one of those things.
We do use a lot of satellite data for hurricane tracking. There's a lot of good GOES data.
Yeah.
But
in any event, I was thinking of the Hurricane Hunter airplanes.
Yes.
Would you rather go in a Hurricane Hunter airplane through a major hurricane, and let's make it a Cat 5, what the hell?
Might as well.
Or go into the mouth of an active volcano in those spacesuits that they put on, those silvery spacesuits and everything, with the jars on the end of the long metal poles so you can scoop out some molten lava that's bubbling out and capture gases. Which is your particular thrill, Jam?
I want to do both.
You can only do one.
Hurricane Hunter.
That
I'll
wasn't
trade
really
you.
supposed to be why it was going to be the Stumper.
You can do both, and I'll do neither.
Well, if we have to pick, I'll do Hurricane Hunter.
And I'd do volcano.
Okay, interesting. Why?
I'm not a huge fan of flying as it stands anyway, so just throwing a hurricane into the mix is just not pleasant in the slightest. Whereas volcanoes, I think, are cool, and I feel like there's more I can control. I know it's still relatively insane, but I feel more in control of the situation.
Go ahead.
Well, I think my inclination would be the same as yours, even though I've been on some wild airplane rides.
Yeah.
Including airplanes that do these crazy maneuvers, but in a controlled, deliberate fashion. I'd be a little bit worried about barfing big time on the Hurricane Hunter ride. And
You would also be worried about having to go to the bathroom, probably.
I think I would wear a Depends.
Yeah.
I would just be
This is a little
psyched
TMI
out.
for the listeners, but it's often a problem one.
As soon as you tell me I can't go to the bathroom, I have to go to the bathroom, and I think that's totally normal.
It's also always really cold on the parabolic airplane flights, and your body's doing weird things and stress.
Makes you want to go pee. Sorry, makes me want to go pee.
I mean, I learned having gone to the I did the Mission Space ride yesterday at Epcot.
Oh yeah.
And it was very much I do not want to be an astronaut, not even a little bit.
Even from Mission Space?
Even for Mission Space, I'm
haven't
like,
done
Why?
it's just like a fake launch thing, and you experience a few G's or whatever.
Yeah.
And I'm like, it's just not a thing that appeals to me
The G's
at all.
were unpleasant to you or something? Oh wow.
I'm just not into it.
I get nystagmus or whatever it's called on that one with the spinning, but that's a whole separate story. But in any event, I like the volcano thing because I could go over. Are you trying to not?
I'm chewing off mic.
Chewing off mic.
But not off camera.
Because I like to think that if I needed to, I could, hop around to the other side of the volcano caldera and take a leak. So that's fine. And I would have this illusion of greater safety. But I have the feeling that more people have died doing scientific collections at volcanoes than hurricane hunter plane accidents.
So here's what I'd say about that is probably, volcanoes are relatively unpredictable.
Right.
Whereas when you're flying in an airplane with the hurricane hunters,
it's designed to take that. And
they do flight tracks that they've planned out, and they understand what is going to happen,
what the forces are,
and what the forces are. And I'm not flying the plane, but I'm on it, and and then you fly into the photos.
It would be cool.
Picture,
it would
eye
be
wall.
cool.
Do you know what? Just WhatsApp me the photos, and that sounds great to me.
You can just see them on Twitter.
Okay.
Usually I often post them on Twitter. Speaking of which, though, how are you feeling about this impending hurricane? It'll be your first.
I wanted to experience some sort of hurricane type event. As long as everything actually turns out fine.
Sure, yeah.
If it actually goes to horribly wrong, I don't want to be that person that was
wishing
for
it. Right.
Yeah.
Why can't we ever have a good earthquake here
right?
in California?
Because everything at home is just mild in every way. There is no extreme of weather.
It's a good description of rich people. Just kidding.
So yeah, it's just nice to try something a bit more wild.
Adventurous,
Mm-hmm.
yes. Mm-hmm. Well, today we'll talk about asteroids getting hit and hitting asteroids. But first, this episode of Walkabout the Galaxy is brought to you by Vortixicity. Livening up your day from the swirls in your morning cup of coffee to the whirlwinds of tornadoes and the devastation of hurricanes, Vortixicity lets you put a new spin on life. Vortixicity is adaptable to your needs. Taken from the curl of your flow velocity, Vortixicity can give you that spinning feeling even with linear motion in a shear layer, or vanish in an irrotational vortex. Ooh. Listeners of this episode of Walkabout the Galaxy can get a free vortex generator. Just mention Astroquarks when you order. So don't just blow smoke, study a smoke ring with Vortixicity. Vortixicity, designed to delight.
That sounds... Thanks, Vortixicity.
I like that they're throwing in a free giveaway.
Me too.
For the listeners. Most of our sponsors don't do that.
Yeah, I love a good promo code.
Astroquarks. Yes,
yeah.
Promo code Astroquarks. Yes. Designed to delight.
Designed to delight. Is it a technology-related thing?
Yeah.
Okay. Well, it could have been a candy bar.
Is it?
No.
Is it like a whirlpool sauna?
It is like a whirlpool sauna.
Just say, is that the answer?
It's whirlpool.
Yeah.
Nice. I don't think I've ever gotten a Stumper.
But it's Whirlpool the company, not like a whirlpool sauna.
Correct.
Okay.
Oh.
I'll take it.
I don't think this. Yes, you get it. Yeah.
Cool.
I think we'll give you.
I have a Whirlpool fridge. Maybe. I have some appliance that's Whirlpool.
On our way to the Artemis corner, we'll take a saunter down the JWST alley.
Can we have a brief detour to the
dartboard?
No.
Oh, come on,
man. We'll go back to the dartboard in a minute. That's after the corner. You got to go around the corner and then you'll go to the dartboard.
Okay.
No, this is just the we haven't done nerd.
We haven't done
nerd news or TV shows and stuff in a while, but we just started watching. We're very late, but we just started watching. Sorry, Hannah.
Star Trek
Lower
series.
Decks.
Oh, yes.
Star Trek Lower Decks.
Very entertaining.
Which is the animated show that's currently on, and it is highly entertaining.
Yes, and it's delightful for Star Trek fans especially.
Because there's a lot of references to episodes there's a lot, but it's also just sort of a fun, quirky characters and silly things happening.
It's a happy show.
Yeah, we like it.
Yeah.
Also, though, there is another show that
Andor has started on Disney Plus, another Star Wars show.
There was something else.
It's about people who are dead before they're dead.
Is it?
Yeah.
Oh, it's about a character who is now dead in our minds.
Yes.
Spoiler alert if you haven't seen Rogue One.
Yeah.
There's another TV show that I can add to Nerd News that's coming out. Okay.
That's remarkable.
I know. It came up earlier today and I spotted it. Haven't seen it, but it looks good. do you remember Quantum Leap?
Of course.
Yes,
So there's a reboot.
There's a new one. There's a reboot.
And apparently one of the episodes, they go into, there's a space shuttle astronaut episode.
Okay.
Nice.
That's cool.
So yeah, keep an eye out and check it out.
There's a Korean show that is using the Quantum Leap premise.
Oh.
And then I saw a French show on Netflix called The 7 Lives of Leah recently that also used the same premise of popping into somebody else's body.
Who's the new Quantum Leap? Who's the new leap person?
Let's see.
Is it a lady? That would be fun.
No.
Anyway,
don't know.
It doesn't matter. Is Scott Bakula going to be making special appearances or anything?
Maybe somebody will jump into Scott Bakula.
Oh, I went to IMDb and the first thing was Quantum Leap. Oh, it's that guy. He's funny. I like him. His name is, I don't remember what.
It's that funny guy.
But it's that guy. He's funny.
It's that the name of that actor that you can't remember actually was a sponsor of Walkabout the Galaxy once upon a time.
Wait, what does that mean, really?
It really was. I'll look it up for you. I had some pretty weird sponsors.
Wow.
I still have some pretty weird sponsors. It's strange how all the strange sponsors are coming to me, the strange Astroquark.
That is strange.
Okay, so now back to the JWST alley.
Raymond Lee is that actor's name.
Good deal.
Okay.
JWST. Who?
JWST alley. JWST took a picture of Neptune.
It was a cool picture.
Which was kind of amazing. So cool. Because...
a Neptune plus 50 galaxies.
Yeah, in the background of every picture.
As per usual.
In the background of every JWST picture,
galaxies.
there are many galaxies. But this was kind
galaxies
of amazing.
Galaxies are the new dust.
Because I remember when we didn't know what Neptune looked like, really. And we didn't know if it had rings. We kind of thought it did from these stellar occultations, but we didn't have any pictures. And then Voyager got there in 1989 when I was alive.
I
and
was
you
too.
were too, barely.
Yeah, I was alive.
And you weren't yet.
You weren't yet.
Not quite yet.
Yeah. But I remember that, and it's like, wow, we have pictures of Neptune, and look at that, pictures of rings and things. And that's like, now we have another picture of Neptune where you can see all this stuff going on. You can see the rings quite clearly. You can see all these little tiny moons, and you see these storms, which we will come back to in our trivia on Neptune. And it's very exciting. It's an infrared picture, so you're seeing the glow from the
glow.
Anyway, it's just very cool.
It's super cool. Yeah, I've seen a few
very nice
pictures, and it's annotated. And then there's like a close-up version that people show where you can like really see everything pretty well. And then if you zoom out a little bit, you see this bright spiky star, but it's not a star. It's Triton.
Whoa! Is that what that is? I'm just looking at it now.
Yes.
That's the backwards moon of Neptune, Triton.
Wow.
And
which is kind of
and
like
it's brighter than Neptune because of the wavelengths we're observing in.
Yeah.
That's
very
really cool.
Isn't that cool?
Yeah. So that's the JWST alley, which takes us to the Artemis corner.
Sad old Artemis corner.
Sad?
Sad old Artemis corner.
Oh.
Yeah.
It's like lore.
Safe Artemis corner.
Safe Artemis corner, as it should be.
Yes.
But, Ian is just ruining the party. And
Ian, who invited him?
Who
anyway?
invited
No
Ian?
one.
He was not invited. So everyone who's involved in like deciding when to launch was holding off, waiting to see these different paths of the impending kind of storm, and they brought out the trawler. Is that
Crawler?
Crawler. They're not floating it back to the VAB.
Crawler. These people that keep making comments on my posts online.
So they brought the crawler out, and they had to decide, we're going to bring SLS back. But it means that they can change some batteries and...
Yeah, so it wasn't clear if they were going to try
to
it.
change the small sat batteries, are they?
Well, they might.
They might charge them up.
You think?
So if they have to replace that, so they might have to replace batteries, and it's the batteries for the warp termination system. Right. So it's that those won't last much longer than the first week of October or something. Right. So it depends on how long it has to be in.
Well,
and probably since they're rolling it back anyway, they will
do
that. But if
October
they do
7th,
that, I think they have to do enough that they might be able to charge up the ones, or either replace or charge up the ones that the CubeSats.
Because what I was reading today is that it's unlikely it will launch in October. Really, it's probably going to be November now.
Yeah. So, and it's like the week of Thanksgiving, November.
Oh well. Yeah. So Artemis rolling back thanks to Ian.
Yeah. It was. I mean, I don't know if the last update we had on it was that the sort of they did a fueling test again.
Yeah.
And they've
was
been
a
having
success.
all this issues with the cryogens
With
and
the
it
leaking, everything.
leaking, and there were still some little leaks, but mostly it went fine.
Yeah.
Yeah, they still managed to fill the tanks.
I think
Yeah.
I think they were able to understand what the heck was going on with the leaks.
They fixed one thing, and now they understand better. And
Yeah.
So.
And part of the leak, like they can tolerate a certain amount of leakiness, and they were able to, sort of like me when I'm on these planes.
Exactly.
And they were able to
That is what my Snicker was about.
see that the leak rate went down as they filled it up and the pressure increased, things like that. So they're like, I think got to the point where they were like, we understand this well enough and we can live with it.
Yeah.
So that's good. Yeah. Let us talk about D.A.R.T and
D.A.R.T.
the other asteroid impact news before I drop some trivia in your brain.
Great. So today we talked about D.A.R.T some last episode.
Yes.
But as a refresher, the D.A.R.T is the double asteroid redirect test. Which is a little bitty spacecraft mission that's going to hit a little bitty moon of a little bitty asteroid to test what happens.
Yeah.
And it's basically like now-ish, right?
It's the
time of recording.
Yeah, now-ish. So we could actually in like 15 minutes the like live stream starts. But
Okay.
It's a spacecraft that's hitting this moon the asteroid is called Didymos, and the moon is now called Dimorphos, but I'm still going to call it Didymoon. And the asteroid is supposed to hit it, and it
the spacecraft.
Spacecraft is supposed to hit the moon, and technically it's a binary asteroid system. So they sort of orbit a common center of mass, and this little moon is mostly orbiting the bigger thing, but they call it a binary asteroid system.
And last time we talked about this little Italian CubeSat that's been ejected so it can record the impact as best as it can.
Yeah.
Which is fun.
Yeah, the D.A.R.T spacecraft will be taking images pretty much as long as it can, and then it'll go.
So the first test is, did you hit it? So that's the first thing. It's like, you got to actually hit the damn thing.
And I was telling my students this morning in class, that's actually hard.
It's not.
We've missed the moon. We've missed Mars. That's not true. Well,
Mars,
NASA hasn't missed the moon in a while, but there have been missions that have missed moon.
But
and
we
Mars.
know how to hit the moon. We know how to hit Mars. We even know how to hit hit the moons of Saturn and things like that.
And we've orbited Bennu and.
But this thing
like that.
This thing is small,
teeny,
and you're coming in.
And we don't have
it's
great
a straight shot.
Data.
It's not like, let me slow down and approach and get anything. You're going as fast as you can.
You gotta trust your orbital dynamics,
which reduces your control a little bit over things.
Yeah.
So the first test is, they got to hit it, and assuming they hit it, then the second test is figuring out what happened to the Didymoon, and that will take some time because it's going to be a lot of astronomical measurements of the orbit of that thing and comparing it to what the orbit was before.
So that'll be a lot
it's
of.
not making a big difference.
No, and it'll be ground-based telescopes that are helping to make that.
Yes.
And I think some space-based ones.
Yeah.
So we'll see. I have kind of mixed feelings about this whole mission.
Yeah,
but
that's fair. I mean, I think it would have been better as it was originally scoped, right? As it was originally scoped, it was paired with a European mission, and there was more spacecraft data, and there was other things that were going to go on with it.
Other sciencey stuff besides just smack into a thing.
Yeah,
and see what you did to it.
And I think that there's going to be a lot of good coverage tonight, and then we're going to know some stuff, but it is going to take a long time to really figure out how much we changed its orbit.
Right.
And if it's a rubble pile-y thing, it might not, it might absorb a lot of the impact, right?
Well,
you're changing the mass.
Ultimately, the momentum is conserved.
The momentum will change. Yeah.
I mean, the spacecraft
the
plus the Didymoon, the momentum is conserved, and we know what the momentums of those two things are in advance. And so the question is, how much stuff gets blasted off in the other direction by the impact? And that's kind of it.
Yeah.
So when in intro physics we have a classic question is, if you want to shut the door by throwing something at it, are you better showing a super ball, a bouncy ball, or the same mass clay that hits it and sticks to it? And students typically choose the clay ball because it sticks to it, sticks to that door and pushes it, but it's the bouncy ball because it delivers not only all of its momentum, but then the door delivers the back off. So there's twice the change of the door's momentum. So that's what the experiment is. This is rubber ball or clay ball on moon.
Yeah.
Diddy Moon.
Diddy Moon.
Yeah.
But this links quite nicely to another story, another asteroid story.
That's from our distant past. But also potentially a binary asteroid story, which is why it's another nice
okay,
tie-in.
cool. Yeah, I want to hear about this.
So there's a recent paper, which we know we like to talk about the asteroid impact that killed the dinosaurs. We're always looking for updates on Chicxulub. But this one actually isn't about Chicxulub. It's about this other crater that they're calling Nader Crater.
Nader Crater?
Mm-hmm. Which is kind of a fun name, right?
Sounds like a
Nader?
A mean name,
like Ralph Nader.
Nader Crater.
He does.
a mean playground name.
Yeah. So this is a crater that, let me make sure I say the right place where it is. So it's a crater that they've recently, so it's underwater. Where is it?
We can come back.
Off the coast of Africa.
It's off the coast of Africa, yeah, thank you.
Off the west coast of Africa, I believe.
Yes, so it's like pretty far away actually from Chicxulub, which is in the Yucatan.
Yeah. It's an Atlantic Ocean away.
Yes, indeed. And so it's a crater that's buried under around 300 meters of sediments and 900 meters of water. So it's actually like a subsurface buried crater. Like we don't see the expression of it very well on the surface.
Even on the seafloor.
Mm-hmm. Even on the seafloor.
So is it radar that has kind of shown
It
this?
is, yeah. Right. You said, I know, we got a lot of radar going on.
Yeah, but it is a radar theme.
It's a radar theme. So they use, they use like bathymetry, right, where they're trying to probe what the seafloor looks like. And they found this feature that they are interpreting as an ancient impact crater because of the structure of the seafloor. So they see sort of very classic crater formation, which is that there's a lot of compaction in certain areas and sort of slopey compression, and then there is like a central peak type feature also.
So that's
buried
cool.
beneath the sediments. So that means it's a big crater, yeah. Also, go ahead.
I was just going to ask if we knew whether or not this 65 million years ago, like what was it like at that time? Was it underwater at that time?
It was probably still underwater, but it was closer physically to like Yucatan than it is now.
I see.
Right.
Based on seafloor spreading,
right.
It's spread apart over time.
Okay.
Yeah, it's in the Guinea Plateau, which is off the coast of Guinea, which makes sense, in West Africa. And currently it has relatively shallow, it has like some different, anyway, doesn't matter. Back in the day...
back in dinosaur day.
Yeah, back in dinosaur day, it was a little bit closer to where the Yucatan Peninsula is now. But so they found this crater and they did a bunch of modeling, as one does, to try to understand how it might have formed and what the impact might have looked like. Well, look at that like central peak.
Oh, nice.
Isn't that nice? Yeah. We'll put a link to the listeners and the viewers. That really indicates that there's a lot of like this crustal modifications. And based on some modeling and then some dating based on other sediments that they have, they think it is fairly coincidence in timing, so within like a few 100,000 years to the Chicxulub impact.
Before or after, do
we
know?
A blink of an eye.
After.
Okay.
But it's a blink of an eye, and they are still working on age dating it a little bit better, and that can make a big difference in what the results are. But that's like, astronomically speaking, to have a big crater that close in time to this other big giant crater that happened is very rare, unless they're somehow tied to each other. So there's two different theories that they look at, which is one that it would have been like a binary asteroid, and it would have like hit then because their orbits would have been perturbed sort of at similar times, and one would have hit and then the other one would have hit. But the sort of more likely thing is that it's something sort of like Shoemaker-Levy 9 on Jupiter, which is a thing we've observed in our our lifetimes.
Yes.
Which is that like sometime in the past history, before the Chicxulub event, there had been an asteroid that made a close approach, and its orbit got perturbed by the Earth, for instance, or by Jupiter, or by somebody, and maybe the primary body got pulled apart or something, which leaves sort of a chain of smaller bodies
In the same orbit.
in the same orbit, but then can hit in different parts of, over time, they hit the surface. So that's sort of the more likely event, probably. But there's still a lot of data they need to get from the crater itself, and a little bit more modeling in terms of when it would have hit and how clustered these events might have been, and if there might have been other craters then to find.
Oh, the
too.
poor dinosaurs didn't have a chance.
I know.
Yeah.
It was just one after another for them.
Yeah, and that's the impact cluster scenario.
They did have a good run, though.
They did.
Tens of millions of years.
Yeah.
Yeah. Before we get to our other planetary topic and our extraplanetary topic, let me drop the trivia on you, which is related to our sponsor.
It's not related to dinosaurs.
No.
Okay, that's fine.
It's related to vortices and vorticity. So we've talked about Hurricane Ian, which is now moving into the Gulf of Mexico as we record this. Our trivia today has to do with vortex storms, if you wish. In the Atlantic, we call them hurricanes. In the Western Pacific and Indian Ocean, they're called typhoons. But every one of them is a cyclone, which means a circulation around a low pressure system.
Okay.
And they circulate has to do with the fact that the Earth is a sphere and rotating, so there's a Coriolis effect that deflects the air that's being pulled into this low pressure system, such that in the northern hemisphere of the Earth, around a low pressure system, it rotates counterclockwise. So if you imagine looking down from, say, the space station,
as one does,
on a hurricane in the northern hemisphere, it's going counterclockwise, and if you look down on the Earth's North Pole from the space station, it's rotating counterclockwise.
Okay.
So cyclones, hurricanes, systems around a low pressure system circulate in the same direction that the planet does.
Okay.
Fun fact.
Okay.
You can also have an anticyclone.
Yeah, you can.
Which would be circulation around a high pressure system. So instead of the air being pulled in and circulating one way, it's pushed out, and that gives you a circulation in the opposite sense.
Cool.
Okay. So that's all your context for the following series of trivia
Is that
questions.
Cyclone 101?
Yes.
Right.
Here are your questions. Which planet in our solar system has the most atmospheric vortices at any one time?
Okay.
We've seen all the big planets and even the little ones long enough and well enough to have a good answer for this.
Okay.
And by at any one time, so I'm not looking for an exact number. So if the Earth were the answer, I'm not looking for the number is probably a few at any one time.
Right.
Averaged over the year and all the different oceans. At any given time, there's a couple maybe.
Okay.
Something, right? So that kind of answer. Which planet and how many? Then I'll have some follow-up questions after that. Okay. So that's going to be your questions are going to be about cyclonic storms or anti-cyclonic storms, vortex storms in the solar system.
Are you ready for some more wild guessing?
Yes.
I am.
Cool.
I love wild guessing. Now let's hear about Mercury.
Mercury.
I'll give you a hint on the trivia.
Not
the
Mercury.
home of
Not
the
the
most,
answer.
The atmosphere rich Mercury. No, so the atmosphere Mercury is very poor, non-existent. Right. So we have some results that have been retrieved from Arecibo. Probably some of the last results. This is obtained in 2019. When was the collapse?
2020.
Was it 20? Yeah. So this is one of the last few studies, I imagine, then out of Arecibo. So there are some radar measurements taken of Mercury that have been compared with some, I think with some topographical measurements obtained from Messenger. So this is now a defunct spacecraft around Mercury. And together they've been looking at, in particular, the ice-rich regions of the poles. So we do love ice-rich polar craters, both on the Moon and Mercury. And some of the data, with this combination of the radar and the topography, they've been able to find that they can see differences in the concentrations of ice in the crater. So sometimes you'll have this even distribution in the crater, and sometimes you'll have a strong concentration, and then it kind of is gradually depleted outwards. So this is showing there's different processes that are going on that affect how the water ice is distributed. So are there impacts that are coming in into these craters that's causing this irregular distribution. And so can we look at the distribution of water in a crater and identify any impacts and try and pair up, well, when were the impacts? Is there like a timing relation that you can bring in? So if it has this much distribution, then it was been impacted this amount over this period of time.
Okay.
And so I think that's what they're trying to relate, because not all of the craters have got this kind of distribution of water. Sometimes it's just really heavily concentrated in one place. And so they're just trying to, it's the first time they've really noticed this variety of ice concentrations, and they're trying to basically understand it better and then hopefully apply it to other planetary bodies like the moon, where it's going to be really important for us to identify ice-rich regions.
Because it's it's astounding to see water on Mercury. It's the closest planet to the sun. It's quite hot in
but
that
not
part
in
of the
those,
solar
everywhere.
system.
Not in the craters, in the poles.
But then you have these permanently shadowed craters like we do on the moon.
Yeah.
It's not a place we're likely to be doing, like we talk about for lunar ice and Martian ice, in situ resource utilization and pulling water out of the soil and processing it and pulling out the oxygen. We're not going to be doing that at Mercury anytime soon.
No.
But it really has a lot to tell us about the history of water in the solar system, as well as you were saying, some of the similar kinds of processes going on at the moon.
And not only the history of water in the solar system, but like knowing this, it gives you ways to constrain models about Mercury's history as a whole, right? Because if you have these cold traps and you have these regions that have to have been cold for eons, right? Like, and you can constrain how long they have to have been cold to make deposits this thick and stuff like that, or what the impact flux has been over time. So it can tell you a lot about like Mercury's history too.
And hopefully the upcoming Bepi-Colombo mission is going to be able to help even more. I think there's going to be some instruments that can evaluate, again, water concentrations in different ways. And this is all derived from these earlier messenger results. So there's this kind of like this ongoing, we've learnt something new, let's send a spacecraft, or let's do some more measurements. And it's just, I feel like we're in the middle of a great investigation into Mercury's poles. And just looking at a map, we were talking about before the recording about the naming mechanisms of Mercury's craters, which is quite nice because there is a Tolkien crater, and then a few others that I probably cannot pronounce correctly. But
that's why it's going to be fun to hear you try.
Oh no!
Yes.
The only one I can do, Chesterton. That sounds like a name I can say.
There's like an Icelandic one.
Yeah, with a lot of G's. But yeah, named after what you say. It was arts and literature, like.
Well, you said there was a Kandinsky.
Yeah, Mercury's craters are all named after artists, like writers, painters, sculptors, artists in general.
Yeah. They're really nice.
Cool. Well, in our extra planetary news.
I was just gonna. I think like the interesting. I was just gonna do one final thing about the ice and the craters.
Sorry.
No, you're good. It was just that like I think it's interesting to see. You mentioned that like we used messenger to infer sort of what the ice concentrations were, and that they were sort of unevenly distributed. And so this like radar data gives you interesting, different data that tells you something about maybe the thickness of the ice. So like if they see the ice deposits in certain craters, but like not in the surrounding areas, it may tell you that there's thicker ice in certain areas than others. That's pretty. Right. It's interesting to like have these different constraints that tell you different answers about this distribution and like what I don't know what Bepi-Colombo has. Does it have a neutron detector? If Bepi-Colombo has a neutron detector, it will give us a lot of good
additional complementary information from a different sort of blind wise man
with his
touching the elephant. Right. Yeah. Well, jumping out of the galaxy, in fact, to the measurements from the Event Horizon Telescope Consortium. I think that's what I say.
The EHT.
Yeah.
The EHT.
They have imaged the shadow of black hole event horizons against for two supermassive black holes. One in the galaxy.
We already know this.
Yes. You stow your fake amazement.
Okay.
The M87 supermassive black hole, the one in the center of the Milky Way galaxy, the M87 one is much bigger and but much further away, but it turns out to be somewhat easier to observe.
Partly because it's bigger.
Yes.
And it's not toward the center of our galaxy.
And we're not looking
which has
through.
all this other crap.
Right. Yeah. So
Galaxy crap.
there's something that I didn't know about with these things. There's a feature of a black hole called the photon sphere. So we're seeing, when we see these orange donut pictures of these that have been taken by the D.A.R.T.
I remember that famous one. Yep.
That's light from this big accretion disk, outside the event horizon, that the light from the far side that's going up gets bent over, so you see it. You always are going to see a complete ring.
Okay.
Yeah.
Right. No matter where the disk is, like even if you're looking at it edge on, you're always going to see the light forming this circle on the sky, and the part in the middle is the event horizon shadow, basically, on all the emission that's coming from that big mess of accreting material around the black hole. Well, the photon sphere is the region of space where a photon would basically travel in an orbit around the black hole.
Oh, because it can't escape.
It can't escape. So you could imagine putting it's the last photon orbit.
The last photon. That sounds like a really cool film.
That's a new Disney movie coming up. So
it's a very short movie, but it seems really long.
Right.
Or is it the other way?
So there's been a paper that's come out this year that's contested, disputed, controversial, claiming the detection of what's called the photon ring from the M87 black hole, which is light basically from that photon sphere. So that is...
How is it escaping, though?
Well, so this is the part that I don't totally understand, right? It has to get to us. We're seeing it somehow.
The photon needs to escape that
somehow,
gravity or whatever is happening.
So I don't have a very good answer to that question. But basically the photon ring is photons that are originating just outside the event horizon in a very narrow region that produces a particular photon signature that is in these images from the EHT added together with all of the light that's coming from all the material around the black hole. And this paper purports to have detected the photon ring for M87, and there's many authors here from EHT group, but a paper contesting this claim has also been submitted for publication. And,
love the drama.
Yes, some scientists describing the claim that the photon ring has been detected as, quote, preposterous.
Preposterous.
That's bold.
Basically what you're doing is you're looking at this giant signal and you're trying to figure out whether or not you can say that this 1% of that giant signal is due to this particular phenomenon, and I'm making up the number 1% because it's more complicated than all of that.
Yeah, of course.
And too complicated for me to understand all the details of what's going on. So it involves modeling. Take a black hole. What would the photon ring light look like?
Yeah.
Then take a look at what we actually see. Subtract what we think it would look like from what we see, and try to piece all that together to determine. It's like, yes, and so that's what they think they've done.
Definitely what
it's
we
like,
see.
Yes, we've definitely seen that in this light. If we subtract all this other stuff out, we have a photon ring part of our total signal that's consistent with what we would expect to see. Therefore, we have seen it. Anyway, we'll revisit this. We'll revisit this.
I can't wait to see the next paper.
I have two comments. I have two comments, which is the first one is that when we were reading about
this... It makes some nice pictures, though.
It does. It makes nice pictures. And also there was a comment that we have images of M87 in polarized light now, which I don't know if we've talked about, but are super cool that we have that. So that tells you a lot more information if you can tell...
About what's going on in the vicinity.
About what's going on in the vicinity if you can tell polarization, because it tells you about magnetic fields, which is super interesting. And the second thing is just a snarky comment, which is that the title of this paper is The Photon Ring in M87 Star, because the asterisk is always used
Oh.
to refer to like this supermassive black hole at the center of a galaxy, right? Like Sagittarius A star. But whenever you see an asterisk at the end of something, you think like, oh, that means there's like
I actually thought that's what it was.
there's like a
think...
comment or a subtitle or a footnote, but it's just because it's M87 star.
I didn't realize that.
Really?
I totally
Awesome,
was like the photon ring in M87 asterisk, and I thought, that's weird. They put a footnote on the title.
Of the paper.
Yes.
But maybe the asterisk. But in light of what you were just saying, the asterisk is like, well, maybe it's not actually.
Maybe
a
not
photon
secretly.
ring.
Yes. Asterisk. Maybe a preposterous claim.
Yes.
All right. Well, let's see how you do with your wild guesses, Hannah.
Whoa, that already has almost 12,000 downloads.
Oh, the paper on the photon ring.
I thought you were going to say citations.
Yes. Which planet in our solar system has the most atmospheric vortices at any one time, and about how many?
Jupiter.
Addie says Jupiter. Hannah says
Neptune 12.
Oh,
how
you
many?
gave a number.
She's
Do we
giving
have
a
to do
number.
both?
Yes.
37.
Addie's going to pull this one. It is Jupiter with hundreds.
I thought 37 was low.
Yeah.
But I was hedging my bet that it wasn't
doing
Jupiter.
Price is Right rules.
Yeah, I was hedging my bet that it wasn't Jupiter, in which case it would be lower, which doesn't make any sense actually.
Yeah.
But
what fraction of those vortices
what's
on
the actual
Jupiter,
number?
Hundreds.
Okay. Order of magnitude.
What fraction of the atmospheric vortices on Jupiter are cyclones? The same as circulating around a low pressure system like a hurricane or a typhoon on Earth.
Is the Great Red Spot a cyclone or an anticyclone? Do I know the answer to that question?
That would be like a lifeline. Do you want to use a lifeline?
No. I'm going to save my life. I'm going to phone a friend.
20.
20% are cyclones?
20% are cyclones and 80% are anticyclones.
Oh, is it one or the other? There's no... Yeah, okay.
It's spinning. It's a rotational thing. It's according to our sponsor, Vortixicity, is going one way or the other.
Yeah, so you got to split it. How do you split it?
There's no third option. Otherwise, it's not a vortex.
35.
Okay.
35, 65?
Yeah.
I'm really curious to know how you arrived at that.
I'm going to go that it's 60%. I'm going to go the other direction of 60% cyclones.
60% cyclones. Okay.
And so 40% anticyclones.
Okay. Hannah wins this one. Yeah. It's only 10% are cyclones. 90% are anticyclones, including the Great Red Spot.
I thought it was one.
Yeah, the Great Red Spot's a high pressure system, not a low pressure system.
I should have stuck with my earlier.
You should have.
It was just you were like, what?
No, I just wanted to make sure you knew what you were saying.
No, I had no idea.
Yeah.
Yeah, you did know what you were saying.
But you made a great stab in the dark.
Yeah.
Yes.
Yeah. I'm good at that.
Yeah, it's interesting, right? Because on Jupiter, there are all different levels too in the atmosphere. Because the stripes we see on Jupiter are stripes that are like different levels of the atmosphere for a lot of.
Right. So Jupiter's first a lot bigger than the Earth. And
True.
It's rotating a lot faster.
I forgot about the whole scale thing.
Yes. And it's rotating so much faster. And one of the things that's disruptive to the formation of these things on the Earth is you're over water, you're over land. And as we know, as we will find out shortly with Hurricane Ian, once it gets over land, it's going to dissipate.
Dissipates a lot more.
Over these gas giants, you don't have topography to mess things up.
So
you get these storms.
To be fair, in Florida we don't have topography either.
It's even so.
But we do have land.
Even
it's not
so, it is
ocean.
enough to disrupt a vortex. So for the Great Red Spot, actually, it's been observed for centuries.
True.
And it seems to be shrinking, though.
I know. Isn't that crazy?
Originally, I think the earliest sort of really reliable measurements on the size were about twice the diameter of the Earth. It's now down to less than 1.3 times the diameter of the Earth. So it's shrinking. Meanwhile, there's a little spot underneath
Global warming.
That is getting bigger, a white spot, OV2 or something like that, that's gobbled up a couple of neighboring cyclones. Has a cyclone ever been observed on Mars? We've ruled out Mercury.
I'm going to say yes. Because they have dust storms.
They do have dust storms.
And I know there are dust devils.
There are dust devils, but I'm talking about global scale where the Coriolis effect is what's going on.
Yes. Such a thin atmosphere that it's probably no, but I'm still going to say yes.
You are both right.
Okay, good.
A cyclone 1,800 kilometers in diameter was observed by none other than HST.
Aww.
Back in 1999. Had a big diameter eye. It looks like a hurricane. It's clouds around an eye, devoid of clouds, but it did not last very long. The next observing pass 6 hours later, it was already dissipating, and follow-ups did not detect it at all. That was in April 1999. Some others have been observed as well, but that's kind of cool because this is a really thin atmosphere. And then finally, what is the duration of the longest observed thunderstorm on a planet, and on which planet?
This is not a cyclone. This is a thunderstorm.
This is lightning, basically.
Lightning.
Yeah.
Neptune. And 20 years.
Wow.
I don't think that's correct.
Earth. 3 days.
3 days on Earth. So you think there's been a thunderstorm thing going somewhere for 3 days and nights on Earth?
I have no idea, right?
And you think we've been observing Neptune continuously for 20 years, able to pick up lightning storms on it? No, the way to figure this one out is which planet have we had the longest really good continuous observations of? With Venus would have been a reasonable guess, except it doesn't have that. But Saturn.
Oh, okay. Yeah, I would never have known.
There was at least a 7 or 8 month-ish
was this
lightning
Cassini
storm
observations?
with Cassini measurements. Yeah, where they're picking up the radio emissions from the lightning.
Oh, fun.
Yeah. So
that's fun.
Yeah.
Do we have spacecraft? Oh, I have so many questions. Could Cassini have picked? Well, not Cassini, but do we have spacecraft that pick up the radio emissions from Earth of lightning? That's fun.
I think so.
About.
Yeah, Whistler waves are produced by lightning, aren't they?
I think so.
Yeah,
they can be.
I think, and so I don't know at the present time but there's so many satellites up there in Earth orbit right now.
Yeah.
I'm sure that some of them are picking up Whistler waves.
How?
If not, let's make a CubeSat to do it.
Yeah, but I'm also thinking about like extrasolar planets.
Picking up lightning from extrasolar planets?
Not like today doing that. But thinking about like other ways to do detections of things on other planets, right?
Yeah.
It'd be interesting.
Yeah.
Anyway.
That's tough.
It's yeah.
We're not a strong signal.
No.
Yeah.
What about aliens? Can they detect our lightning?
I've been watching War of the Worlds.
I haven't.
Yeah. Well, it may have felt like waiting for a hurricane to arrive. It was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the universe. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel and catch up on old episodes wherever you get your podcasts. Follow us on Twitter
at walk_the_galaxy.
And ask us questions anywhere by emailing wtg@ucf.edu. Screw #AskWTG. Our theme music was composed by Richard Barusik. Production assistance is provided by Logan Basinger. Thanks to our listeners in Tampa Bay, Florida, and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Hannah Sargent.
We're the Astroquarks, signing off until the next episode of Walkabout the Galaxy.